Example 2a, if I'm asked to find the slope of the graph at all these different points here, I just copied down the derivative that we just found, and I'm just going to substitute in, and don't be afraid, it's okay that the derivative have both x and y in it. The way we're going to express our work, if we're going to write dy dx, and then for the domain where x is equal to -6 and y is equal to 4. And then we're going to, or some people like writing it as -6 comma 4. They write it as an order pair, whichever. It's just a preference or a stylistic thing. But we're going to substitute in those values into the formula we found for the derivative. So let's see, we get 2 times -6 for x, and then 3 times 4 squared minus 2 times 4 minus 7, so which is -12 over 48 minus 8 is 40 minus 7, so 33. So that's going to give me -12 over 33. The -11 over 33 would be about a third. So let's see if I sketch here, does that slope look like it's about a third? I think that looks about right. It's a little steeper than a third, but so we definitely estimated it correctly. Now I want you to pause the video and then find the other 4 points. Maybe for one of them, try to use proper notation just for practice. This is what I got for the other 4 points. And again, you can kind of estimate it. Look, to make sure you did it right, or maybe you lost a sign. So at -4, 0, -4, 0 is right here that I'm circling on the graph. And I can see that 8/7 is a little bit steeper than 1. And to me, it definitely looks slightly steeper than 1 there. And the same for at 4, 0, it's this way. It's going like that way, a little steeper than at the point 3, 1, which turned out to be -1. And then because the graph is symmetrical, it also makes sense to me that these two slopes would be opposites of each other. And the same for -4 and 4, when x is -4 and x is 4. It would make sense that those two are opposites of each other. Where does the graph of y cubed minus y squared minus 7y minus x squared equals -16 have horizontal tangent lines? Well, horizontal tangent lines happens wherever the numerator of the derivative is equal to 0. So you would say dy dx is equal to 0 when 2x is equal to 0. So when x is equal to 0. And if I wanted to find the ordered pair for which that happened, I would have to then substitute it in, because it's saying where, it's not saying at what x. So I'm going to give the ordered pair. So I would then substitute in when x is 0 into the original equation. So we do y cubed minus y squared minus 7y minus 0 is equal to -16, like that. And then we get y cubed minus y squared minus 7y plus 16 is equal to 0. Now, this is not an obvious one, but I would then either go to my graphing calculator and solve it, or I could use the solver. In this case, there's no trig, so the solver would work just fine on the TI-89. Or I would go to the grapher to check where it's equal to 0. So using the graphing calculator, just to show you, I entered the function. I used x instead of y, but at the ultimately, I'm trying to figure out where this function right now is equal to 0. So I could do it using the grapher. Go into graph. F5 is math. Choice number 2. I need to make sure I'm to the left of the 0 I want to find, enter. But the key is I can see that there is only one 0, that it doesn't occur anywhere else. And that's going to be at -3.0379. Or I could have used the home button where I use the solver, and remember the vernacular is y1 of x is equal to 0, comma, for x, I'm solving for x. And again, I can see it's negative 3.038. So that means once we solved for, it's going to be at the point, at point 0, comma, and then we got negative 3.038 using at least 3 decimal places for that one. And there you have it. All right, at what points does the graph of this relation have vertical lines? Well, that happens where the denominator, so dy dx is undefined at, or when, I should not say at, but when, we're trying to figure out where the at, when 3y squared minus 2y minus 7 is equal to 0. I have 2 ways of doing this then. I could either solve using the quadratic formula, or I could use my grapher as well on the graphing calculator, or I could use the solver on my graphing calculator if I would rather have that, and then find the coordinates for those. So in that particular case, going to the grapher, I have entered the quadratic that we wanted to solve. Again, I'm using x. I know that it's supposed to be in y, but it just makes it easier for this problem. So in this particular case, I entered our function for the denominator there, and we get then, I deactivated, you could either use the grapher to solve. I'm just going to use the solver. And the way to do that, I've already done it once, just double check, but we're going to go into F2, the solver, choice 1. I have it in y2 of x. Don't forget to use function notation, equals 0. And I want to solve for x. Enter. Oh, I have 2 solutions. I can either write those 2 solutions down, or I can store them in my calculator. So the way to store them, either type the answers out, or I can move up and grab them. So if I highlight that and hit enter, the problem is that we have a whole bunch of extra things that I don't need right now. So I'm going to delete the second solution, the or, and I need to go over and delete the x as well. So at the front, you see I'm using the arrow key and I'm deleting the x. Now it is ready to store. So the store button is above the on button where it says store. And then I'm going to store it in letter A. So I have to use the alpha button, that's the white button, and then read above each of the letters. Above the equal sign is the letter A. So I'm just going to use the letter A for that one. Oops. So it's stored in A. I want to store the negative version in B. So I go right back up using the arrow key to the previous where I solved it, and then hit enter. It goes down in the active bar. I'm using the arrow key so that I get to in front of the solution where it says x is equal to, and then I'm going to delete everything else. I don't know why that's highlighting like that. There we go. Everything goes so that it's only the solution. It's not set equal to anything. It's only the solution. Let's store that. So using the store button, alpha, letter B, enter. So right now in the calculator, in the letter A, I've stored the square root of 22 plus 1 over 3, and in the letter B, I've stored the negative square root of 22 plus 1 over 3. So that means when y is equal to 1 plus minus the square root of 22 over 3. That's when that happens. But I want to find the ordered pair, so I have to that's why I used the store button. I have to substitute them back in and solve for the corresponding x's for that. So in this case, by the way, I can see that it happens just in the picture in lots of places. It happens here, it happens here, it happens here, and it happens here. So I'm going to go into the calculator and substitute in for y all of these pieces here, like that. So I'm going to take, but conveniently, I've stored the two possible solutions for y as a and b. So instead of writing a squared, or I mean, like, instead of retyping in this each of those solutions, we have now we've now saved them into the calculator. But we have to do a little bit of solving. So now I'm going to ask the calculator to solve for me, but wherever I had the variable y, I'm replacing it by a, which I had stored in my calculator for one of the solutions for my y from before. And I have substituted in wherever the letter y is, I've substituted in this value for a, but I've asked my calculator to store it and then put it into the equation. The only unknown essentially is the x in the x squared. So I'm going to ask the calculator to solve for x, n parenthesis, and enter. It's probably better. This looks really, really messy. So instead, I'm going to ask it for decimals. So here, okay, that's a little more manageable. So we are going to write those two down. It's going to be positive 2.439 and negative 2.439 for those two. And it may be nice to have a as a decimal as well, just to be on the safe side. So we do alpha, I just call it up, alpha a, and then give me the decimal notation for that. And it is going to be 1.897. Okay. Now we do the same for B. So now I don't want to have to retype everything. So I'm going to go up and grab my directions from before, hit enter, and then where I'm going to use the arrow back key, and wherever I see the letter A, I'm going to go ahead and put the letter B instead. So then I erased one of the A's, and I'm going to put the letter B and go back. Don't hit delete, go back. The arrow back key, and then delete the A, and then alpha B, and go back to this one, delete alpha B, and enter. Really messy, but guess what? I'm just going to do second or the diamond enter, and it's going to give me decimals. That is 4.608 for the second y, or for the letter B. And I'm just for, because I'm using decimals, it looks less messy, I'm going to use the decimal here. So the B was negative 230. And I have to include the 0 because I'm rounding. So now I have all of the pieces that I needed. When y was, let's see, 1.897. My x was 2.439, and it was both the negative and the positive version of that, 439 and 1.897. And when y was negative 1.230, then I had both positive 4.608 and negative 4.608 at negative 1.230. And there you have it. Let's see if it holds true. Let's test one of them. Let's see, around 2.5 and 1.9, there should be a vertical. So around 2.5 and 2.5 and 2, almost 2.5 and 2. That's that one right there. Okay, that seems right there. And then the other one, -2, that's this one, -2.5-ish, and 1.9, that's that